Telescope. The telescope is used to provide angular magnification of distant objects, figure 9.29. So this is the figure 9.29 which NCERT talks about. So this is for the angular magnification. Angular magnification का मतलब क्या है कि how much the angle is being subtended at the eye. Like for example, if suppose there is a star far off, and this star is giving is sending the rays. So therefore, if I am seeing, the angle subtended by the star on the eyes is alpha. Okay, so let us go ahead. It also has an objective and an eyepiece. So this is the objective and this is the eyepiece. Both are convex lens. But here the objective has a large focal length and a much larger aperture than the eyepiece. Okay, why it has much larger aperture? Now, this lens has a greater, bigger diameter and aperture because the light rays are coming from far off, and therefore to have good amount of intensity of the light, so we have to collect as many rays as possible for the intensity to be good. Therefore the diameter is more, or the aperture is little more. Okay, like if you have small lens, so only these many rays can insert, but if you have big lens, then many rays can insert. So therefore the intensity of the object and of the image is going to be better. Going ahead, light from the distant object enters the objective and a real image is formed in the tube at its second focal point, which is shown here. Okay, the light rays, they enter here and therefore we see an image which is formed here. Okay, we see an image which is formed here. Okay, since the object is at infinity, because it's a telescope, we are going to see objects which are at a farther distance away. Okay, so therefore the image is going to be formed at the focal length of the objective, so therefore FO. Okay, we can see on the focal plane of the objective the image is formed. Okay, the eyepiece magnifies this image, producing a final inverted image. The magnifying power m is the ratio of the angle beta. Okay, now the eyepiece, what does the eyepiece do? So eyepiece, it takes this image, and what we have done is we have very nicely, very like expertly, we have put we have put the setup in such a way that the image is formed at the focus of the eyepiece. So therefore the image is going to be formed now at infinity. So this side it's at infinity, the object is the image is going to be formed, final image, and it's going to be inverted. Okay, let us go ahead. The magnifying power m is the ratio of the angle beta subtended at the eye by the final image. So now we see this is the final image. This is the final image, and the angle subtended by the final image at the eye is beta. So therefore the magnification is going to be, okay, let us first see final image to the angle alpha, which the object subtends at the lens or the eye. So therefore the magnification is beta by alpha, which is FO by FE. So let us prove this, how this becomes magnification beta by alpha becomes FO by FE. Let us prove this. So this object is here, okay, like far away. So therefore I can write here that tan alpha, like tan alpha, I can write here as the I can equate it to be like alpha because it's quite far away and all. Okay, so we are approximating. Now if you see clearly, this alpha is same as this alpha due to geometrical optics. Okay, so now if the image is formed here, okay, we can see this alpha equals h by FO. or basically tan alpha becomes h by FO, which we have like equated to be and approximated to be alpha. Okay, fine. So this alpha is the, like if suppose the lens was not there, and we are just seeing the object with our naked eyes. So with our naked eyes, again it's going to subtend at an angle at alpha only. So alpha is equal to h by FO. Okay, now for the second image, so have a, like let us look very clearly and let us try to understand this. Okay, not very difficult. So now because the image is formed here, so therefore these rays are like actually after passing through convex lens, they are like the image forms at infinity. So this is one of the rays. Okay, it goes like this, and this is also one of the rays. Since the image is being formed at infinity, these rays are going to be parallel. Now whatever ray like it comes, okay, whatever ray it comes, again this ray will also be going, this also will be going parallel. So there will be also one ray which will be passing through the optical center, and this ray also will be parallel. Okay, all these rays are going to be parallel, and that's why we kind of extrapolate it backwards. So now since this is also going to be parallel, therefore this is also beta. Okay, so therefore tan beta, okay, because these rays are parallel, so therefore this is beta, this is beta, this is beta, all the angles are going to be beta. So therefore tan beta, you can see very clearly, this is h by Fe, which we tell as beta. So now the magnification becomes beta divided by alpha. So this is h by Fe into alpha is h by FO. So h is gone. So therefore the magnification is FO by Fe. Okay, let us go ahead. So we can see the magnification is FO by Fe. In this case, the length of the telescope tube is FO plus Fe. The terrestrial telescopes have in addition a pair of inverting lenses to make the final image erect, because the final image what we were getting was inverted, although it's at infinity, but it is inverted. Refracting telescopes can be used both for terrestrial and astronomical observations. Terrestrial means like on the ground observations. For example, consider a telescope whose objective has focal length 100 centimeter, FO is 100 centimeter, eyepiece focal length is 1 centimeter, so therefore the magnifying power becomes FO by Fe, that is 100. Let us consider a pair of stars of actual separation 1 minute. So what's going to happen? That they the magnification increases their separation 100 times. So therefore 1 minute into 100, that is 100 minutes. So this is 1 degree 40 minutes. So therefore that is 1.67 degree. So 1.67 degrees is like quite significant as compared to just 1 minute. Okay. So this is the astronomical refracting telescope. Thank you.